So for example, suppose we have to do the integral from minus infinity to plus infinity. Now instead of e to the power I, we have some function, say f of x, which is x squared plus x plus 1. For Jordan's lemma, it's important that this function has big powers in the denominator, because that only then you're going, the contribution from this part is going to go to 0 as r goes to infinity. If it has powers of x in the numerator, that's not going to happen. And here we have sine of x. This is not exactly, like that function, but what Jordan's lemma is saying is that if you can figure out the function like this, of course, this is a complex function, it will have a real part and an imaginary part, and the real part and the imaginary part you can equate. Okay, so here we have basically the imaginary part of this thing, right? So to do this, what we do is that, okay, we want to look at the imaginary part of this integral. Okay, so in other words, we want to complexify this function like this. And then we want to find out what the poles are of this guy in the upper half plane. Okay, and you can very easily show that the poles in the upper half plane are minus half plus minus square root of 3 by 2 of I. And now if I use Jordan's lemma and take the imaginary part, then I have minus 2e to the power minus square root of 3 by 2 pi sine of half divided by square root of 3. Okay, so this is show. It's a few lines of algebra. Okay, so any questions?
Sir, we know the case for omega greater than 0 and omega less than 0, right?
Yeah.
Or so what would be the case for omega equals to 0, or did I miss it?
What would be the case for omega equals to 0? That would not be included in this case. It'll be something it would be the previous case essentially. Okay.
Oh, okay.
Yeah. No, that's good.